Firstly, I will talk about why we're using wireless power transmission and a little bit of history. Then my friends explain close and long distance wireless power transmission. And finally, brief application areas, startup, and future of the technology. In history, Tesla found wireless powers and its transmission in the late of 1890s and able to transfer energy from one coil to another coil. He managed to light 200 lamps from distance of 40 kilometers. Also, he built a tower for wireless power transmission in 1901, and he said that all people can have access to free energy, but he cannot find any investments, so the tower never operated and the project was abandoned in 1906. So, why we are choosing wireless power transmission? Wireless power transmission is the transmission of energy from one place to another without using wires. The wireless transmission is more efficient because averagely 30% of energy is loses during transmission due to resistance of wires, the size of wires, the atmospheric conditions like temperature or humidity. This is where the WPT comes into action. It is highly reliable, fast, low cost for maintenance, and can also be used for close range and long range distance transmissions. But wireless system has own problems because it can lose some energy when transmitted. Even though the idea was developed hundreds of years ago, scientists are still working on the efficient way for wireless transfer of power, but for the last couple of years, wireless system is averagely 10 to 15% more efficient than wire system. So we all can see WPT system in our life. For example, wireless charging station for our mobile phone. Also, as EE students, we can observe that wireless power transmission have been using for transformers, which is most common WPT application. Now, Emre and Kaan will brief you about wireless power transmissions method.
So, what is the first thing that matters to us when transferring power wirelessly? Yeah, it is distance. So we have to decide whether the device we will charge is close to our power source or far away. Therefore, we can examine the wireless power transfer methods under two main titles, close range and long. And I will talk about air ionization as the first method for close range. It is taught as technique under near field energy transfer techniques because conduction is by air and it also needs very high electromagnetic field. The second one is inductive coupling. In inductive coupling methods, primary and secondary coils are not connected to each other with wires, so power is transferred by mutual induction. Even today, we use this method when charging our phones. Wireless charging pad, electric brushes, and transformer can be example of this method. The third method is resonance inductive coupling. It is based on magnetic resonance and it is possible to transfer the far distance compared to the inductive coupling method. Resonance is the tendency of a system to oscillate a given frequency at maximum wavelength, and this frequency is called resonance frequency. Objects with the same resonance frequency tended to transfer energy with high efficiency. So this is the simple resonance inductive coupling circuit. This circuit is actually LC oscillator circuit, and these type of circuits are called tank circuit. Before diving into the LC circuit, we need to understand a simple RC circuit. The capacitor is fully charged initially, and we can observe that the current flow is at the maximum, and then it sharply decays with time. This is expected because the current has to be at the maximum. At the beginning, charge difference at the maximum. So the current will flow. Let's see what will happen if the resistor is replaced with an inductor. The capacitor is again fully charged. The current flow starts from zero and increase to the maximum, and then comes back to the zero again. An inductor capacitor circuit, the current flow variation has to be gradual, and we can see that the current flow in LC circuit is shaped like a sine curve. After reaching maximum current value, then the current from the capacitor starts to decreasing. An ideal circuit, this back and forth flow of current would continue to the charge and discharge. And also we can control frequency by changing the values of L and C. At the end, magnetic energy creates a current on the receiver coil, so we can transfer power wirelessly. In all these methods, power is transferred wirelessly. But for example, the phone needs to be on a pad to charge, or vehicles must be very close to the charging station. Yes, these methods are useful for people, but if you want to do something wirelessly, we need to think bigger. So what if the phone in our pocket continues to charge while we are sitting at home? or our car keeps charging while driving. For this, we need to transfer power over a long distance.
I will talk about long-distance power transmission. There are two types of long-distance power transmission, which are laser and microwave. I will talk about microwave due to more spread of usage area. Microwave is efficient, reliable, and fast. The most important feature is longer distance, I think. We can send power to longer distance with this amazing technology. If I will give information about the working principle of the technology, there are two parts, which are transmitter and receiver. And as you can see at the lower left corner, the devices that want to charge broadcast a pilot signal. These signals are focused by microwave power transmitter, and microwave power transmitter determine the location of receiver. The charging process will start over long distance. However, there should be no obstacle between receiver and transmitter for proper and smooth charge. One of the efficient technique is beamforming. This is a technology based on optimal beamforming delivers highly efficient microwave power transfer. Beamforming, in other words, smart antenna technology, detects our devices and broadcasts a signal directly to it, not having the signal spread in all directions. Some places where this technology is used. The technology in factory areas. Factories these days use a lot of sensors and devices which can be arranged more freely with wireless power transfer. Using optimal beamforming, the electric power can be transferred for long distances. For the below picture, charging vehicle batteries, when the vehicles are stopped, battery charging process will start. This technique will be beneficial for logistics, cargo, and transportation companies. Moreover, we will be able to transfer energy just like we do information with the help of beamforming. In real life, Toshiba used this technology and they make it move the train, and in addition also they turned on the light at the same time. Now, if we consider behind the scenes of these charging processes, I want to talk about the block diagram of microwave charging. The above side is transmitting and below side is receiving part. First, microwave power source produces a microwave with microwave generator, and then microwave will pass through coax waveguide adapter, which offers a convention transition between waveguide and coaxial transmission line. After this process, the waveguide circulator, which reduces the radiation to exposure from outside power. Lastly, tuner and directional coupler separates the signal according to signal propagation direction, and transmitting antenna broadcasts the microwave signal to receiving antenna. The signal passes through a low-pass filter, which reduces the frequency of microwave for necessary network. Lastly, the rectifier, which can be a bridge rectifier, converts AC to DC power, which is necessary for our charging devices. We get DC output and the charging process will start. Now, my friend Berke will continue about other details.
Thank you, Kaan. I continue with application areas. Many of the products currently being developed on wireless transfer technology come into our lives in the following areas, which are consumer electronics, automotive, medical, industry, and energy. By meaning consumer electronics, mobile phone, laptop, remote control, etc. Over the next 2 years, the most vibrant wireless power transmission will be the contactless charging of portable and mobile equipment in consumer electronics and electronic vehicles. Next field is automotive. A wireless charger for electrical vehicles has been started and developed recently. In some production vehicles, in-car wireless charging pads have started to be offered as an option. From the figure in the right, there are studies about charging of medical products such as a pacemaker while inside the body. In industry field, SD microelectronics, which is the newest charging product, has proprietary high voltage technology paired with mixed signal design and highest quality assurance. This field meets the global QI standard to ensure compatibility between QI compatible phones and other electronics and chargers, such as from starting iPhone 8, Samsung S6, etc. In the next slide, in energy field, from this figure, we can see the solar power plant is installed on the moon, and the generated energy is sent to Earth using wireless power transmission technology. As a future project, it involves building a belt of solar cells around the moon, 6,800 mile equator, converting the electricity to powerful microwaves and lasers to be beamed at Earth, and finally converting the beams back to electricity at power stations. The electric power generated by solar cells will be transmitted by electrical cable cables to transmission facility on the near side of the moon. After the electricity is converted into microwave beams and laser beams, 20-kilometer diameter antennas would beam the power to receivers on Earth. In the next slide, the startups for wireless power, which are Energy Square and Momentum Dynamics. In Energy Square, this wireless charging technology design includes microcontrollers and conductive tiles in the right figure. Crucial advantages for this startup is multi-charging, full-speed charging, efficiency, and no energy loss. The technology can be embedded easily in any device with minimal constraint. In the next startup, which is Momentum Dynamics, develops high-power inductive charging technologies for automotive and transportation industries. The technology is modular and scalable, allows any type of vehicle to be connected to the electrical power without any wire. Imagine your electric vehicle charging itself anytime and anywhere. By giving example, this is a mass transit bus. It charges 7-10 minutes every hour, up to 16 hours per day. And this is a good start for the startup. For the system design, the charging system is a modular design consisting of 4 charging pads, as in the figure, connected in a parallel on the vehicle, with each charging pad capable of delivering 50 kilowatt of power to the battery, as Emre mentions about resonant magnetic induction. These figures can be examples of future project of wireless power. And we have also references. We have tried to explain wireless power transmission basics, method, application areas, and the future project. So thank you for listening us.